Welcome to Advanced Data Analysis 1 with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. In this video, we'll be looking at Homework 3 and combining into one large R Markdown file, Homeworks 1, 2, and 3, as setting the stage for a larger document where we will continue to build our homeworks. The second part of this video is about working in RStudio in R Markdown when we're writing code, working in the console to debug issues, and then compiling and some of the differences there. So here we've got the course website, and I'm going to zoom in a little bit here and scroll on down to the timetable. And above the timetable, we currently have a file, Erik's NESARC data, nicotine and depression. There's the Markdown file, and there is the HTML result of that, but I'm not going to look at these two right here. Instead, I'm going to pretend that I loaded this into RStudio, which I have loaded a version of it in. Here we are in RStudio, and I'm going to open up that file up here at the top. Okay, so here is the NESARC project, and in this document I basically have homeworks 1, 2, 3, and part of 4 heading into the future. So let me maximize this top window, and notice that the YAML, which stands for Yet Another Markup Language, that header section doesn't include any extra business, right? We have the title, we have the author, we have the date where I've put in this additional command which will automatically put in today's date. And the way that works is within the two back single ticks, the two left inverted commas, the first command is R, which says that R is going to interpret the next command. And working from the inside out, as you do with functions, I first look at the systime, and if I go to the console down here at the bottom and run capital sys.time, open and close parentheses, that gives year, month, day, hour, minute, second, mountain daylight savings time, the time zone. And that time is then formatted to be in format BDY, which is the month of the year, the day of the month, and the year of the century. All right, so if we take a look at what actually, so let me compile this document, and we'll take a look at that. So I'm going to knit the document, and we notice we have a new R Markdown tab. It goes ahead and compiles it and opens it in a new window. I'm actually going to view this within my browser, so I have a little bit of more zoom capability, which looks a little better on the video here. So no, September 1st, that happens to be today. And I've got a table of contents produced, homeworks 1, 2, and so on, with main sections, subsections, so the sections, right, those start with a pound sign. The subsections start with a double pound sign, and the subsections start with a triple pound sign. So I get some nice indentation there in the beginning of chapter 4. Now, this is probably, homework 3 is really the first time you've interacted with code. So I want to show you a little bit of my workflow for how to solve problems with code. Everyone has some trouble writing code. Some of us have, over decades of writing code, have become very good at fixing problems, but you'll sort of always have problems writing code, and you'll get better at fixing the problems that you have. So let me scroll on down here. Here's homework 1. That's the personal code book. There's all the code book stuff. Homework 2 was the literature review, so I've got my research questions there. I'm going to scroll on down. There's some citations. And homework 3 is what we're working with this week. We've got the main goals are to subset our data set and then provide univariate numerical summaries and plots. That's our goal. So I've restated the purpose of the study. I don't really need to do that because it's above in the first two homeworks. I have the variables, which were already in the code book, so you don't really need to copy those here. And then finally, data subset. So here's where the coding starts. So at this point, I'm going to jump back over to RStudio, and I'm going to maximize my editor window. And I'm going to scroll on down to homework 3. There's homework 2, literature review, and I've got, let me see if I can fix all this gray stuff. Starts there. Page down a little bit. Okay. So here's homework 3. So I happen to have a lot in this document extra, and you are certainly not expected to have all this, I'll just say junk in this file that I have. So try to keep it neat and tight. So I've got the purpose of the study. I don't really need that. There's a variable list. I don't need that because I've got it in the code book already. And now here is the data subset subsection. And if I just remind us where we are, here we are in the HTML file, and this is the data subset. Okay, so first the data is placed in the search path using the PDS package. So I've loaded the dataset package there, and then finally the data sets are available. Now recall, I had knit this file earlier. In fact, I'm going to do it one more time because apparently I made some change. Okay, so one would think that because you have run knit, and of course what knit does is it reads through the file, it interprets all of the R code, it produces the results, and it incorporates both all the text, the commands, and the results all in one file. So you might expect that the variables are in your environment where your variables are. But if I look at the right top window here, environment, my environment is empty. I have no variables over here. If I ask, okay, if I run what is the dimension of Nisark, it's not found. And you may find that this is counterintuitive because it's got to be found. I just compiled my document and it produced output, so why isn't it found? This is the reason. It's because when I click knit, there are two separate environments. There's my working environment that is represented in the upper right environment panel, and where the variables can be accessed in the console. And then there's the R Markdown environment. When I click knit, notice there's the second tab down here. In the knitter environment, it did go through and it compiled all this code. So all these little % signs here on the right hand side and that bar that moves across from the left to the right, that's each time it sees a code chunk, it runs the code, it has the results in memory and so on. But all of that is not available to us. It was available only to the R Markdown knitter process. So that means that when you're debugging code, you manually have to go through and run every line yourself. Now there are some shortcuts to that, and I'm about to show you what those are. So recall from previous videos, if your cursor is on a line and you press Control Enter, it will submit that line into the console below. So I'm going to clear my console, and in the editor window in the top left, I'm going to press Control Enter. It will submit that line down to the bottom, and I'm going to run those two lines with Control Enter. And I see down here that I've got 43,000 records and 3,000 columns or variables in that data set. Now, it would be a very laborious process to go through arrowing down and then pressing Control Enter for every line of code. So there are faster ways. In the top right hand corner there is a chunks menu, and in particular there's these three run previous code, run current chunk, and run next chunk. And so right now my cursor is in this chunk with the var.list. So if I do Control-Alt-C, that will run this current chunk. So I'm going to do Control-Alt-C, and all of those commands just got submitted below. Okay, the var list all the way down, and it's done. Okay, so now if I were to type Control-Alt-N, which almost all of you will be able to do. Unfortunately, I actually can't do that because I've mapped that key to do something else on my computer related to my task manager. So I'm going to click it in this menu, but I would recommend everyone learn this command. On a Mac, it's something like Alt Command left apostrophe or something. So I'm going to run next chunk, and what it did is it just jumped down to the next code chunk and it ran these lines. Let me scroll up in my console down below, and you can see it ran the dimension line above as well as the structure of the subset above. Okay, so that's a handy way to start running the chunks, and you'll notice that in the top right corner in my environment I have a subset. Oops, I clicked on it and it opened it up. The NISARC subset as well as the variable list. Okay, so those are active in my environment. I can see those variables and I can use them. So this next code chunk, for example, another way to do it is I held the shift key down and I selected a bunch of lines by pressing the down arrow. And if I press Control Enter, that's like this run button up here, that will submit that whole, everything that's highlighted down to the console. And each time I run a command, so what did that command just do? This was the rename command. It renamed my variables. So if I scroll up a little bit in my console, in fact I'm going to maximize the console for a second, the previous structure of the data set had the original variable names. For example, S3AQ3B1. And now that I've run the rename command, if I look now at the structure of the subset data frame again, I now have a structure of the data frame that includes names that are easily understood, names for humans. So smoking frequency or daily cigarettes smoked, okay? Tobacco dependence rather than these other strange variable names. So what I recommend as you're working through writing code, at every command that you run, you want to inspect the object that you just created. So when I ran this line, I wanted to look at what was the result. I looked at this I created this new object, or rather I updated the previous object. I need to look at what that is and see whether the result matches my expectations. If I get a warning or an error, or maybe I just labeled something in a strange way, I need to know immediately, because the next commands are probably going to depend on the previous commands working. All right, so summary is another way of taking a look at this data frame, and for each variable I have either a frequency table, ID number is not interesting, sex, okay, is an ID variable, or age is a continuous variable. I have a 5-number summary as well as the mean. So you really need to be at each command that you run, running that command from the editor window in the top left, looking at the result down in the console window and seeing if it matches your expectations. If not, you need to go back and continue to make changes. I will give a warning about one strategy which is probably tempting, especially at the beginning when you're learning to code. You might look at my example and you might go through the code and you might delete things that don't belong, and you might just go ahead and fill in your variable names the way you think, and so on. And then you compile the whole thing and you get a bunch of errors and you wonder why. And so that process is tempting because you want the computer to understand what you meant. Unfortunately, computers only understand ones and zeros. And so you really need to get every little detail correct. A very common mistake, for example, in this variable list is to choose variable names that are accidentally are capitalized differently than you expect. For example, a good code book will be very consistent about capitalization, but some might make mistakes. So for example, I don't have an example of a code book that did that, but so this data set, let's take a look at this. So let me clear this. The dimension of the NESARC data set has 3,000 variables in it. All right. So how can I find my variables and see what's going on? So one strategy is to look at the column names of NESARC. And if I do that, I'm going to press enter. It's going to print out the 3,000 variable names. All right, good luck finding your variable. They're not in alphabetical order or anything. So what you can do is, I'm going to go down to the bottom here. I'm going to press the up arrow. The up arrow will recall the previous statement. So I'll press up. There's column names. And in fact, if I continue to press up, it will scroll through all the commands that I ran previously. All right, so I'm going to go down to the bottom and just do column names. So I'm going to wrap the column names in sort. Okay, so sort the column names. And I'm also going to press Control L to clear the console so that there's nothing else in there. And press enter. I get all my column names in order, and I can say, okay, so I was looking for, let's see, here's a S3AQ. All right, so let's scroll up here. S3A, holy moly, S3AQ 3B1. Okay, so that's the variable name that appeared in the codebook. It happens to be exactly the same in this data set, so that is the correct label to give it up in the editor window. So if there's a mismatch, the thing to do is to look at the actual column names in the data set and double check everything. And when in doubt, I'll tell you what, I would never, because I don't trust myself, I would never just type this. I would look at the column name, I would look it up, and I would find it. Did I find the right one? S3AQ3B1. And I would Control C copy, and I would go up here and I would paste it, and I would use the copy and paste because I know copy and paste doesn't make typos. All right, so let me scroll down a little bit more and just do a little bit more work here. So I'm moving my cursor into each block, and I'm pressing Control-Alt-C to run that code chunk. All right. So occasionally I add in a couple, like a little bit of extra junk because I'm making a point about something. For example, these 3 lines here, the subset command below will not include a row that evaluates to NA, to missing, for the specified subset. For example, and I have an example here, I'm going to press Control-Enter on the NA equals 1. That gives NA. And so the point I'm making is that age, maybe age isn't the best one, but if age was a missing value and you tried to evaluate this, it might evaluate to NA. And then you'd know that the Boolean operation NA and something else would evaluate to NA, and as I say up here, will not include a row that evaluates to NA. So what that means is that subset, the subset function, will not include any rows with missing values if the missing value is either age or smoking status. So there are probably a bunch of smoking statuses that are missing values. We can very quickly just check that out. So how about summary of smoking status. There we have 25,000 missing values for smoking status. Age is not going to be as much of an issue. In fact, there's no missing ages in the data set. So I just wanted to let you know that when you run subset, sometimes missing values go away. Let's see, coded missing values, that's not part, well, that eventually will be part of your homework. So I'm going to go ahead and let you read through this. You know what, I'm going to say a couple things. So, some of the variables, and I need to go ahead and look at the code book for this. I'm going to go up to the homework 1. Some variables have codes for missing values or unknown. So for example, smoking status, this check 321, has a code number 9, which is unknown. So I want to code those as missing value. So if I go back to smoking status, I do actually walk you through what's going on here. So I'm going to look at the structure of the smoking status variable. And there's a 1, a 2, and a 9. In fact, this is a little bit easier to see within the HTML file. All right, so the structure of smoking status has 3 levels, 1, 2, and 9. And 9 is that missing value or unknown status. And, oh, well, it does turn out that for this variable, the previous subset removed any observations there. I think I have a better example here. Here is smoking frequency. And if I page all the way up to the code book, let's try to find smoking frequency. That's this weird S variable here. There is a code 9 for unknown for the frequency of smoking. So I want to code those 9s as being missing. Scroll on down. Coding missing values. Alright, so here we go. When we look at the summary of smoking frequency, we have 3 missing values. So what I've done here is for the smoking frequency variable in the subset data, I have asked which of these smoking frequencies equal 9 and chosen those indices through the square brackets. So for those positions where the smoking frequency equals 9, I'm going to replace the 9s with NA. So if I rerun summary, as I did before, okay, if I rerun it, now the number of 9s I have is 0, but I have 3 NAs. So my reassignment worked. And this is what I mean by you need to check the result of every line of code. Here's a line of code where we changed something. We need to know what it was before and what it changed to, and did the behavior match your expectations. And you need to do that for every command. And the sooner you adopt that habit, the fewer headaches you'll have later on. Finally, for the factor variable for the smoking frequency, I'm going to drop the unused levels of the factor. So 9 is a factor level, and it has 0 observations, and it does no longer appear. It does no longer appear down below anymore. Okay, so we've removed that level. So now we just have the meaningful levels 1 through 6, and anything else is a missing value. And I did that for each of the variables. Finally, once I've recoded those missing values, NAOmit is a function that will remove records with missing values. So here's the dimension of the data set with some of the missing values. So it has 1706 rows. If I run NAOmit, So omit rows with missing values and reassign that to my subset data. Now I've gone from 1706 down to 1697. So now I have a data set with no missing values. All right. I'll let you look at how I've created some new variables. And I'll focus a little bit on labeling variables. And I'm going to focus on labeling variables with respect to factor levels. So, depression, you know what, I need to open one more tab here so I can look at the codebook. So I've got the codebook open here, and I'm going to find my depression variable. Here we are. And the coding for depression is 0 for no and 1 for yes. So when I look at a frequency table and it says 0 and 1, that's not as informative to me as no and yes. So I want to include those labels. So I'm going to switch back over and look at the depression variable. And I'm going to, within the factor function, create labels for each level in the order that those levels appear in the depression variable. So 0 is the first one, and so that label I'm creating is no depression. And then 1 is the second level, and I'm saying yes depression. And actually I want to scroll up just a little bit. Here's depression. So previously, when I looked at a summary of the data subset, I got a frequency table that said depression, 1200 zeros and 400 ones. Now that I have added these labels for the zeros and ones, and I do that for each of the variables, now when I look at a summary of the data subset and find the depression variable, I now have the label that a human can read. So 12,000 no's, 400 yeses. And I think you'll agree that labels for ethnicities and smoking frequencies and everything like that will be much easier to read once you've got the actual words there. All right, finally, we're going to produce some tables. For categorical variables, there's two ways you can do this. If you have only one variable, the function table of the variable will produce a nice frequency table, nicotine dependence or no nicotine dependence. Actually, they're surprisingly roughly equal, though I have selected only people who are smokers. Another way to do the same thing, and in a more general way, because crosstabs, X tabs, will allow me to have multiple variables. So you can have sort of rows and columns. Specify the data set, so data equals the subset. Put in a tilde and put in your favorite variable. And I believe that if it was on the left side of the tilde that you would get this by rows. In fact, I'm going to go ahead and try that out by running lines until I get down to that set of code. All right, so we're getting there. All right, so here's my crosstabs. The line that we were just looking at, in fact, I'll run it again, are these two lines. So I've got nicotine dependence. And so this is something that, it's worth asking a question and trying something out. So I'm going to actually make a copy of this line. And I'm going to move the tilde to the other side. And press Control Enter. And it didn't like that at all. What if you... Okay, so this is probably something that we're going to look at later. It doesn't like that at all. So, yeah, crosstabs just has this notation of having a tilde first. That's just the way it is. Okay. So, had an idea, tried it out, learned something. And graphing we've covered in the previous video on creating plots like this. So effectively I have, for each of these, I've used ggplot to create the plots. I've specified my data set. I have created an aesthetic mapping of the tobacco dependence to the X variable. So along the bottom I've got tobacco dependence on the X variable. And by using the geometric object of a bar plot and adding that layer to P1, I'm going to zoom out just a little bit so I can see everything. And when you zoom in and out, it moves you around the document. I have a frequency, and so I've got about, I don't know, 800 something versus almost 800 for nicotine dependence. I just produced that table, so nicotine dependence, almost 900 and almost 800. So that's what those two numbers look like in bar plot form. A bunch of bar plots. The last thing I show is plotting a numerical variable. And here I have a histogram, which we covered in a very previous lecture. So I assign, in this case, total cigarettes smoked, which is a variable that I created from other variables, to the x-axis. There it is. Oops, estimated cigarettes smoked per month. I've put a histogram on there. Those are the bars. I've put a rug, and the rug are these little tick marks at the bottom that show the exact position of the individual observations. And then I've added an x-axis label. And theme BW actually just changes the background to be white with very light gray lines. Without that, it looks like, how often do it looks like this, where you've got a gray background and white lines. See, there's no theme BW here. So there's a theme BW for black and white, and it has a white background with this light gray lines. That's just a preference. There are other themes, and of course you can choose all sorts of crazy colors. Please do not do that. I've also, in this case, overlaid a density plot on top of the histogram. Is it more informative than the original histogram? I don't think so. All right. So that's the end of homework 3 stuff. I hope that is slightly a helpful video. The main ideas I hope that you get from this is that when you run knit.html, that is a separate environment from your own working environment. And so you really need to go through line by line and make sure that your own code works in your editor window by checking those lines down here in the console. And once you're satisfied that all those lines work from top to bottom, then go ahead and knit. And I will say that sometimes something will work in your own environment that doesn't knit well, and that's probably because you have chunks of code out of order. For example, at the beginning of homework 3, I'm first loading in the data set before I subset my data. So I've already seen examples of this where some of these lines get out of order in a student's code, where, for example, they'll try to subset the data first, and then in some later line, then they read in the data set. And so the way to make sure that everything is working correct, see all my variables in the upper right hand corner? Here's a helpful command down in the console. RM is to remove a variable. And let me remove the list equals ls. So I should show you what ls is. ls parentheses is a list of variables. These are actually the same variables that are in this global environment up here. And so if I want to remove those, there's a couple ways I can do it. I can use rm list equals ls open and close parenthesis, and if I press enter, that will delete the variables in the upper right hand corner. Here I go, pressing enter, and they are gone. Now another way I can do that is I'm just going to create a couple of variables here. X and Y I just created, they have values 1 and 2. There's also this broom which will sweep away everything in my workspace. So if I press that button and say yes please remove these, that also erases my environment. Once you clear your environment, you can then go up to the top of your file and start working through and running commands. And if you run those from top to bottom and something doesn't work, then you know that something's not, well, then you know something's not working, for example. All right, I think that's plenty of homework 3. Hope you're all doing really well with this. It's going to be, this is by far the most challenging assignment we have so far, because most of you have not programmed in R before, or possibly in any language, and we are starting by working with large data sets and doing some computations. And on Thursday we're doing some plotting. So this is hard. You're going to struggle. You're going to make errors are going to pop up in R and you won't understand why. And you have our help to try to get out of this. Everyone is going to be making errors with their code, and everyone's going to be learning how to correct those errors. That is a major skill of programming. And if you persist through your frustration, I feel like I'm giving a speech in the movie Rudy or something. If you persist through your frustration, you will, that's how you become a good programmer, by solving problems and solving small problems one at a time until everything works from top to bottom.